Go ahead.
Okay, good evening to everyone. I'm pleased to introduce Dr. Hyo-Sang Lim. Dr. Lim is a postdoc at Purdue and CERIAS, working on topics related on trustworthy information systems.
Thank you for introducing me. Good afternoon, everyone. I am Hyo-Sang Lim, and today I will present about provenance-based trustworthiness assessment in data streams. And this work is joint work with Professor Elisa Bottino in Purdue and Professor Yang Se-moon in Gangwon National University. Okay, first let's see about the data streams. As you already well know, data stream is a sequence of data element arrives orderly. Network packet data and sensor reading data is a typical example of data streams. And now, recently, data stream is everywhere with new computing environment and with new applications. For example, ubiquitous mobile computing is everywhere now, and embedded systems and sensor networks are popular in many applications. Here are some applications examples. Traffic control systems monitors traffic data from the mobile sensor or sensors on the road. And location-based service and based on user location is popular in many applications. And e-healthcare systems monitors patient medical conditions. And also real data financial analysis handles real-time data from stock market and some currency rates. And what are we interested in these applications and this environment? We can see that data is originated by multiple distributed sources. And also data is processed by multiple immediate agents. And in this situation, we can see that each data can have different trustworthiness. And then assessing data trustworthiness is crucial for mission-critical applications. And we can see that knowing where the data comes from is crucial for assessing data trustworthiness. Here, where the data comes from is data provenance. Now let's see clearly more about what is data provenance. In general, data provenance means the origin or history of something. But in computer science, it has more specific meaning. In the context of computer science, data provenance refers to information documenting how data comes to be in its current state. It includes where it originated and how it was generated and what kind of operation is undergo on the data since its creation. Okay, this is an example of the sensor network and the data provenance. Here, we can see that there are some aircraft monitoring the battlefield. Each sensor or each aircraft has different range of sensing and different accuracy. And each data collected from this aircraft from the aircraft is sent to the satellite, and probably satellite conducts some operation onto the data and send the data to the base station. And the base station forward the data to the headquarters, and the headquarters makes some decisions based on the information. In this example, if all sensors or all aircraft send consistent data, then there is no problem. But if some sensor sends some incorrect data or some conflicting data to the headquarters, it means that we need to assess the trustworthiness of each information. For example, these two sensors, these two aircraft sensing a same region. But let's consider this situation. If one sensor said, oh, there is an enemy movement, but another sensor says, oh, there is no enemy movement, then we need to decide which information is true and which information is false. Okay, then in this talk, I will focus on data provenance for assessing data trustworthiness. especially in data stream environment or sensor networks. And in this talk, I will present some initial solutions for this problem, and also I will address I will introduce some research issues related with this topic. Okay, then let's see what makes it difficult to solve. The first difficult comes from the data stream's nature. Usually, in data stream environment, data arrives very rapidly, and it means that we need real-time processing, and we need high-performance processing. And data streams has unbounded in size. It means that sometimes it is not possible to store the entire data of data items, or we can only access some part of the data, and only we can sequentially access the data. And there is a dynamic and adaptive processing nature in data streams, and sometimes we can only have some approximate or summary data. And another difficult from the provenance nature. The provenance information is annotation of information, and it means that it increased as it is transmitted from the source to the server, and we call it as a snowballing effect. And the last is the network nature. It means that the data is not transmitted to the headquarters by point-to-point method. The data is passed through some networks, and there is some intermediate node that manipulate or just passing the data to the server. Then we need to consider all these things. First, I will present about our initial solution. We call it as a cyclic framework for assessing data trustworthiness. First, we model the sensor network as a graph. And in this graph, the terminal node is a sensor node, and it collects some information, and then it sends the data to the intermediate node, and intermediate node also can collect some its own data and process on the data and send the data to another intermediate node or to the server, and the server makes some decision based on this information. And we also model data provenance as a subgraph of this network, this graph. And our provenance can be a simple path if the data is just passed through one by one in the network. And also, and in another case, it can be an aggregate path, like this tree-like path. And here, some data are collected in some node, and then the node aggregate or summarize the data and send the data to the intermediate node, and the data is finally passed to the server. And in some case, it can be an arbitrary tree. And in this case, our data is sent to some multiple node, and the data can be combined into another node, and the data is passed through to the server. Okay, with this model, we model trustworthiness as trust scores. Then it means that we assess trustworthiness by computing trust scores. Here, the trust score means quantitative measures of trustworthiness. We use a value between 0 and 1. Here, 0 means that the low trustworthiness, and 1 means that the highest trustworthiness. We can use two kinds of trust score for data and one for node. Data trust score indicates about how much we can trust the correctness of the data item, and this means that we associate one trust score for each data item. And another trust score is node trust score. Node trust score indicates about how much we can trust the node produce correct data. It means that we associate one score for each node. And here this concept of trust score provides an indication about the trustworthiness